So in this lecture, we're going to be talking all about the virtual method in C++. We've seen it before, we've used it, but have we fully understood it? Let's see. So the idea of the virtual method is that it allows us to override functions in a base class. We've seen this with things like begin play and tick in Unreal. But let's get further into this and understand why they're marked as virtual. It allows us to change functionality in that base class, and it does something called dynamic dispatch, which we're going to talk about in a second to kind of understand what this really means and why virtual methods aren't the default functionality in C++ as they are in many other languages such as C#. So let's have a look at this. I'm going to be doing this in the cpp.sh website, so that we're not in Unreal here at all. We're just looking at the raw C++ functionality so that you can understand this language feature and how it works. Now, the first thing I'm going to do here is just go ahead and clear out the main method. And in our use case, we're going to think about a class for guns, seeing as this is a very common use case for games. So let's have a look at a class, call it gun fairly straightforwardly. And then we're going to have the body of this class be public and a void shoot method. And I'm just going to go ahead and declare the body of this shoot method right here in line to keep things super simple. By the way, you can do this if you haven't seen this before. But generally speaking, we want to do things in a separate C++ file to keep things separate, to make the compilation times quicker and so on. But here, where it's just a toy example, this is fine. So we're going to do an std cout, so using C++'s output string stuff, and we're going to go bang, basically when we call this method. And then we're going to end line. And that's the body of our shoot method, and we can cap off the class with the curly brace and semicolon. So let's go ahead and actually use this class. I'm going to create a mygun variable in main, and I am going to call mygun.shoot. And let's see if everything is working here as it should. Hit the run button and bang, it is calling the method as we'd expect. Now, what happens if I want to extend my gun and perhaps make a rifle or pistol? Let's call it a pistol. So class pistol is a inherited from gun, which we do like this. And if you haven't seen this before, because you probably haven't written this necessarily before, you do a public inheritance from gun so that other classes can see that you inherit from gun. And then we do, in the public section, we want to maybe create our own shoot method for the pistol that overrides this functionality. And instead of printing bang at the end here, we want to print pew. Because it's a smaller gun, it makes a smaller sound. And that's our shoot method there. And let's cap off the class there. And what we want to do is create ourselves a pistol. So pistol, my pistol, in the main method here. And because these are just existing here right on the main method, we're not using pointers to them. That's why we're using the dot operator here instead of the arrow. So the my pistol dot shoot, let's see what that does. I'd expect it to print pew, which it does. Cool. Okay, so let's remove our methods that are calling shoot directly on these. And let's see how things would behave with a pointer. So I'm going to create a gun pointer called gun ptr. And on the next line, I could do it on the same line, but for simplicity's sake, I'm going to do it on the next line. I'm going to set that gun pointer to point to the address of, that's the address of operator, the address of the mygun variable. And then because this is a pointer, we need to use the arrow operator to call the shoot method. So I'm going to call shoot on my gun. Let's click run, and we get bang as the result there. Cool. Now, what happens if I do the same thing, but instead of setting the gun pointer to point to my gun, I set it to point to my pistol? Let's go ahead and hit run now. Okay, that's an interesting behavior there. What's going on here is it is calling this first method in both instances. So why hasn't this second shoot method been called? We've got a pistol here as the pointer. Well, what happens if you don't have a virtual method is that by default, C++ will use the type of your pointer, which this is a gun pointer, remember. It'll use that type to find the method to call. So it'll go and call this shoot method at the top rather than the overridden method in pistol. In order for it to call the overridden method in pistol, it would have to have a pointer of type pistol. Now, that's fine, and you can see why they do this. It's for efficiency. C++ is all about efficiency. If something is going to cost more when it's compiled, when it runs, then C++ won't do it by default unless you ask it to. So it's very easy for C++ to make the lookup and go, well, this is a gun pointer, so I'll call this gun pointer method. And this is where dynamic dispatch comes in. This fancy term basically means that we don't want it to do that. What we want it to do is say, hang on a second, what's actually stored in that gun pointer? What's the real type there? And the real type, we realize, is it's of type pistol. And so we've got to ask ourselves, is there a method for that type that's overridden? And yes, there is. So how do we give C++ the permission to be just that little bit less efficient and give us the ability to override without having to change that pointer type, which isn't always necessarily possible. In fact, in many cases it isn't possible, as is the case when you're having your own custom actor class. Unreal doesn't have the pointer set up to point to your particular act class. That would require them to change the whole engine every time you introduce a new class. No, that's just not possible. They have a pointer to something of type actor star. So when they call begin play, you want it to call your begin play method, so it has to be virtual. And that is the key here. If we stick virtual in front of the method in the parent class, this now signals to C++ that, hang on a second, if I am calling shoot on a pointer of type gun pointer, I need to check that this isn't, for example, a pistol and that this shoot method has been overridden. So if we go ahead and hit run now, you can see we get bang and then pew. So it is working as we'd expect with dynamic dispatch. And that is the term for this thing, where we basically just mean check what kind of type this is really being held in the pointer and call the relevant method. Now, there is an extra little bit of syntax that you'll often see us use, and that is the override keyword, and you put that after a method that you are trying to override as virtual. And basically, the override keyword isn't strictly necessary, nor is putting virtual again against something on the child class of a gun. So you don't have to put virtual, but it doesn't hurt to do it. But override is particularly helpful because it allows us to just make sure that we've got our naming correct. So if I hit run, everything runs as before when I have override. But say I had mistakenly got the name of this method wrong, so I don't do the override and I had called it, I don't know, shooter, for example. I'd copied the name wrong. I typed it in instead of copying it. If I hit run now, then you see we've got the same error again because we're trying to call to shoot. We mistakenly overrode it incorrectly. It's going bang, bang. So the way I could avoid this is by saying, well, I'm trying to override something, so I put my override keyword in here. And if I try to compile it now, you can see that it's saying shooter is marked as override, but there is no method, no virtual method for me to override, in which case I can go, oh yeah, I've mistyped that, so I'm going to go ahead and correct my code and just make it back to shoot, and now it works as I intended. So it's just that little bit of extra safety by putting that override there. And incidentally, this would also protect us against the case where the thing that we're trying to override isn't virtual. If I try to do that, you can see that it's saying it's marked as override, but it doesn't override because that parent class doesn't have a virtual function for shoot. So hopefully this has given you somewhat of an overview of how C++ uses and implements virtual functions and why we have to be so explicit about them. Now, let's think about some more use cases for virtual functions in general. We've already seen some from the engine. Where have you seen virtual used before? Where can you imagine using it? We've just seen a use case example where you might have a gun and different overrides of that implement shoot in different ways. How else could you imagine using virtual functions that override the functionality in parent classes? When you've thought of an answer to those two questions, go and follow the link to the discussions in this lecture and post your answer there, the use cases and the places that you've used them before, and see what other people have come up with. Maybe that will help you solidify your understanding of virtual methods. That's it for this lecture. I'll see you in the next one where we'll be using virtual methods in Anger.